Okay, today we have a 2008 Ford Edge, 3.5 liter engine. Customer complaint is the engine runs rough idle, no power. So I'll start the thing up and we'll see what we have. Definitely has some roughness to it. Check engine lights on. It has like a electrical burning smell. Doesn't smell pleasant, but put the scan tool on it and see what we have. Only rough in here. So we have a Ford new manual ID 2008 Edge. Oh, that might have been. It's all-wheel drive. 3.5, yes. Engine. Codes menu. Let's do memory codes. Let's see, we have an ignition A, primary, secondary circuit fault, and OBD2 checks incomplete. Not going to worry about the OBD2 system checks. Just means the faults were cleared. Alright, I think Ford uses a mode 6. I don't know if they have a misfire counter, but we can look. Misfire data. Number of misfires 0, and that is definitely not right. And it also says that it is not misfiring, but it clearly is. Let's see. I'm going to do this a different way. I'm going to go back. I'm going to go to OBD2, diagnose, start communication. Continue. We can go into mode 6 and look at the misfires on each cylinder. I believe it's total misfires. And it should say whether it passed or it didn't pass. This would load. Okay. Alright, so here we have our misfire data. Misfire cylinder 1. Not complete. Not complete. I'm seeing no counts on here. Alright, so we'll go back. Misfire cylinder 2. Not complete. Okay, so I have a feeling all these are gonna say incomplete and there's no misfire data, so let's do a different approach here. Alright, so I'm just going to do a cylinder drop test. Kind of sucks because the intake covers up 2 cylinders back here. That's alright. We're just going to look for an RPM change. I'm just going to unplug these ones that I can unplug one by one. Yeah, definitely a change there. Also another change. Just listening for an RPM drop. Get this clip off. Yes, another RPM drop. Plug that back in, and the only other one that I can get to is maybe back here. I don't know if you could see that shake. It's definitely misfiring. And that one's unplugged and there's no change. Back to here. See if I can get my light back there. There's my coil back here. And it's unplugged right now. Plugged in. Unplugged. There's no change. Alright, so I believe that's cylinder 1. I'm just okay, so just gonna do a different approach here. And of course these are not labeled. Thanks a lot, Ford. Not labeled. Just some numbers. Alright, so we need a wiring diagram. Alright, so I have a wiring diagram, and what I'm going to do is locate the fuse for the ignition coil and put my current loop in there and take an amperage reading and look at all my coil ramps. Especially because of this design, it's hard to, I can't get to them because the intake is there. So as soon as I can find my ignition coils. Alright, so here are my ignition coils. Cylinder number 1. And they share this fuse. It is a violet wire. And that goes back. Let's see here. It's a white and brown wire, and it's going to go back all the way to the first page, and that is fuse 33. My amp probe are on my current loop, which is on my ignition coil fuse, which is the feed for all of my ignition coils. And I need to adjust this a bit. So I need to invert it. And let's make this 5 milliseconds. We can go close to 10 milliseconds. Do 50. Back. Zoom out even further. Let's do 200 milliseconds. Better yet, I'm going to zoom in further. 10 amp scale. Okay, 10 amps better. I'm going to change my time base to 2. Yeah, okay, so 20. And then I'll just set up a trigger if I can. Where's my trigger? There we go. Alright, well, they all look the same. I'm going to pause this and just take a look at it. Okay. We are missing the current ramp. This is a 6-cylinder engine. 1, 2, 3, 4, 5. Missing. 1, 2, 3, 4, 5. Missing. There should be 6 current ramps here. We only have 5. 1, 2, 3, 4, 5. And another one. It's missing that cylinder 1. Alright. We have one coil that is not firing. We have one coil that is not firing. Cylinder 1, which is right here. So we have 2 pins, pin 1 and 3. The violet is the shared fuse. And there is a white and violet that goes over here to the PCM. And it gets a ground through the PCM, so that's what we need to check. We need to check this wire and check this PCM driver. I'm just hooked up here to my white and violet wire that comes from the coil to the PCM, which is the ground. Should be false ground to fire the coil, and I am not making any contact. Alright, there we go. Stylus. Just down a bit. And we have a solid 14 volts, 14.3, 14.2. So basically I could have a broken wire from the coil, which is back here, in between the coil and the computer, which would give me an open ground, which is what I have. I have no control to this coil. There's no, I have a missing current ramp. There's no firing at this coil back here. So the next thing I need to do is do a check at the computer on this control wire. So no control to the coil. I need to check this driver. If I have 14 volts at the computer, we have a bad driver in the computer. That will confirm no broken wire between the coil and the computer. Alright, so here's my cylinder number 1 coil, and my control wire is this white and violet that comes down, and it goes to pin 17 at the PCM. It says right there CD1A. Maybe coil driver for cylinder 1. I'm not sure what the A is. I need to check for control, or if I have that 14 volts at this pin. Alright, so I have my pin hooked up. Pin 17 at the PCM. It is this white wire with a violet tracer or purple tracer, the same wire we were doing our checks at right here. And it comes from the coil to the PCM, or from the PCM to the coil. It is the control wire. It is the pulsed ground to fire the coil. And we have 14 volts on this wire. So that confirms that we do not have an open in between the coil and the PCM. And what we have is a computer driver problem. I really wouldn't be against checking powers and grounds at the computer, but I feel like if we had a main ground problem, it would affect more than just one cylinder. But this vehicle needs a computer, and most likely a coil is probably what caused this concern. You can see right here, $14 volts on the ground, or on the computer driver to the coil. And that 14 volts is fed from this fuse, and the reason we have 14 volts on the ground side is because there is no ground in the driver. It needs a computer, most likely needs a coil. You can smell it, it smells melted, something smells burnt, and what happened is probably this coil burned up the driver and the computer. So we're gonna get a computer and coil, maybe all the coils, I don't know. And hopefully I can get an aftershot. Well, it's been a few days. I got my parts. The electrical smell, definitely a coil. I mean, look at this thing. It is definitely melted, and it stinks very, very bad. Got this is the old PCM, and I'm back to just doing my original test. Just got my current loop hooked up, and I'm around the ignition coil fuse. They all share the same fuse, so I'm going to see all the firings. And here are my coil firings. They all look pretty good. I'm just going to stop it and zoom out. Nothing missing in this picture. And I'll put a comparison up of the old shot, or the original shot of the missing coil ramp. But we could say that this is 1, 2, 3, 4, 5, 6, and then it would go on another 1, 2, 3, 4, 5, 6. None of them are missing. In the original shot, I think I have it saved. But I'll put a comparison up. That's definitely a confirmed fix. I mean, this coil. Look at that. And it stinks. It smells so bad. But New PCM, new coil. I took it up to my buddy who programmed the PCM and the keys for me. And that's a fix. Well, we knew it was going to fix it. Now, it's always hard to call a module, but in this case, you know, if it would have been different, if I would have had a no spark and had no coil firings on any of the cylinders, you know, and all my inputs would have been good, my cam and crank, then I would have went on to doing power and ground checks at my computer. But this one wasn't too bad. Calling that a fix. I'm pretty happy I was able to actually fix this one and be able to show it. That was cool. Thanks for watching.